Hello there, this is lesson 4, and today we're talking about physical properties and physical changes. So in the last video, we talked about particle diagrams, what they were, and how to draw them for elements, mixtures, compounds, diatomic, monoatomic, all these different types of things, and how to draw them for solids, liquids, and gases. Okay, so today we're going to be covering physical properties and physical changes. So, a good place to start is to ask the question, what are physical properties? So, physical properties are properties that can be observed without changing the composition or chemical makeup of the substance. So, what that means is that you're not changing, you're just kind of looking at it and making observations with your 5 senses. So, some examples of physical properties could be, color, texture, density, conductivity, the change of state. So, melting, boiling, freezing point, stuff like that. Solubility, malleability, mass, and volume. So the things with the little asterisks are the things we're going to dive into deeper because they may be kind of new. So, going into conductivity. Conductivity is a material's ability to allow electricity and or heat to flow. So if you've ever, cooked something hot on a stove and grabbed, a pan, the pan is pretty hot because metals are generally pretty good conductors. One of the reasons they put plastic handles on these pots and pans is because plastic is not as good as a conductor, so it doesn't absorb as much heat or allow as much heat to flow. Malleability means or is, a material's ability to be able to be shaped or hammered without breaking. So if you think of anything, so let's say a pencil. If you try to bend a pencil, it will snap. So we can say a pencil is not malleable because you can't bend it and, change its shape without breaking. But if you take Play-Doh, you can bend Play-Doh. You can, shape it into different things without it breaking. And if you get metal hot enough, you can actually bend it into different shapes. So that's how all the jewelry and stuff is made. And fun fact, gold is the most malleable metal. Okay, so freezing point, another physical property, is just as you would think. The freezing point is the temperature at which a substance freezes. And again, freezing is when a liquid turns into a solid. The next one is boiling point. And again, the term boiling point is pretty simple. Boiling point is the temperature at which a substance boils. And again, boiling is talking about when a liquid turns into a gas. And I could totally ask you what the boiling point of an element is, and all you'd have to do is look at the reference table, the chem reference table, table S, so the lovely looking chart on the back of the periodic table. So let's do that. Let's have this question. What is the boiling point of gold? Gold is AU. Look that up. Okay, melting point. Melting point is the temperature at which a substance melts. Again, melting is when a solid turns to a liquid, and just like boiling point, melting point can be found on the periodic table, on the table S. Now you may notice that the temperature is in a unit called K, which is Kelvin, and we will talk about what that means when we get to stuff later on. Okay, density. Density is a measurement you could do, so it counts as a simple physical property. And density measures the amount of mass per a given amount of volume. And it can be used to test the purity of something. So if, you're testing, you're, synthesizing a compound, you can see how accurate it is based on what the density is. The density for all the elements are on table S. So go ahead, answer the question. What is the density of nickel, which is Ni? Okay. Also, the formula for density is on the last page, and that's table T. So the next video we go over will be how to use the density formula. So here's a quick picture of table S. Couldn't fit the whole thing on one slide, but it has, atomic number, symbol, name, ionization energy. We'll talk about when we get to periodic table. Same with electronegativity, and literally all of this stuff. Okay. Moving forward. So now that we've covered physical properties, let's jump into physical changes. So a physical change is a change that alters the form or appearance, so what it looks like, what a material looks like, but does not make the material into something new. So you're changing the way it looks, but you're not changing the actual thing. So one thing that's super important is that these phase changes are physical changes. So by phase changes, I mean, melting, so solid to liquid, freezing, which is liquid to solid, condensation, which is gas to liquid, vaporization, which is liquid to gas. So you're still the same object. You're not changing, you're just changing its appearance. So if you have a frozen ice cube and liquid water, it's still water, you're just changing its appearance. So phase changes are physical changes. Another way you can remember that is, phase changes start with the letter P, and physical starts with the letter P. So if you let's think of P and P, that should help you with some questions. Okay, so if we look at this example, stampede's the word. If we want to put it through, the physical change machine, out pops this. It's still the word stampedes, but now it looks a little bit different because we changed the font. That is a physical change. If we take this log, or we take this ice cube, and, we want the ice cube to, go through a physical change, again, that is a phase change. All this is melting. You can go backwards and turn that liquid back into that ice cube. If we wanted to, put this log through the physical change machine, out pops two, we cut in half, out pops two pieces of the log. It is still a log. It's just now smaller than it once was. So again, during a physical change, properties remain the same. It's still the object. So whether or not you melt ice, you shred paper, you cut a piece of wood, you're mixing marbles together, it still acts and behaves and does the same thing. You're just changing what it looks like a little bit. So here are a few more examples. If you crush a can, melting an ice cube, boiling water. So, here's a phase change. Here's a phase change. Phase changes. Mixing sand with water, breaking glass. Here's another phase change. Sublimation. So sublimation is a solid directly to a gas. And if you've ever seen dry ice, that is a super example of sublimation. One of the things to point out, this is a good one, dissolving something in water. So if you dissolve sugar, salt, something in water, it's a physical change because you can get that salt or that sugar back. What you would have to do is evaporate the water, turn it into water vapor, and whatever you dissolved in that water stays on the bottom of the cup. Okay, so here are some helpful hints to kind of help you if you're dealing with a physical or a chemical change. And we're going to talk about chemical changes in not the next video, but the video after that. So first, ask yourself, did you make something new? And if the answer is yes, you have a chemical change. So, if you take a piece of paper and you burn it, you made something new. Now you have ash. That is a chemical change. If you did not make anything new, so you take a piece of paper and you rip it in half, it's still paper. That is a physical change. But if you're not sure, so if you're like, well, I melted an ice cube and now it's liquid. I'm not sure if I made anything new because I started with solid water and now I have liquid water. I'm not sure. Well, then ask yourself question number 2. Can you undo what you just did? So if you turn, water into, solid water and ice into liquid water, can you go backwards and turn that water into ice? If the answer is yes, it's a chemical change. But if you're like, if I'm making pancakes and I take that batter and now it's all liquidy, now it's, the pancakey form. If did I make something new? I'm not sure. So then you ask yourself, can you undo it? Can you uncook a pancake? The answer is no, so that would be a chemical change. So this is a super helpful slide for those of you who need that extra hint. Okay, so question for you. Is melting ice cream in the hot sun a physical change? The answer is yes. You can get that ice cream back. Can you burn a cookie and have that be a physical change? The answer is no. So yes, you still have a cookie, but you can't unburn a cookie. Once it's burnt, it's burnt. And if you look at it on a molecular level, you're actually destroying the compounds that are actually in the cookie. So burning cookies is a chemical change. Okay, last one. Chopping down a tree. Is this a physical change? The answer is yes. The tree is still a tree. If it's standing up, if it's, on the ground, it is a tree. That is a physical change. So that, here's a quick, here's another question I have for you. Now we have a chemical reaction. Now, I want you to notice these little letters. And so S stands for solid, and L stands for liquid. And so, we break this in half where the arrow is. This is the before, and this is the after. So we have a solid water, turning into liquid water. Is this a physical change? The answer is yes. And this is an example of a phase change, because you're changing from a solid to a liquid. And remember, phase changes are physical changes. Okay, so that is it for today. Tomorrow, or next video, we are going to be talking about density in a lot more detail. So that's it. Bye.